Okay, so this is a very short lesson on the dangers of space. Obviously, humans have been kind of exploring the space very close to Earth for a long time, and been to the moon. We have the International Space Station. But these are not these endeavors, going to the moon, going to the space station, even lately, kind of doing this civilian travel in spaceships that are owned by civilians, is not without risks. Okay, and so we're going to talk about some of the dangers that exist in space. And just kind of go through, what these kind of spacesuits can provide. Anyways, probably one of the largest dangers of space is that, here's some of these pointers. There's radiation. You have extreme temperatures from 120 degrees in the full sun to minus 150 degrees in no sun. There is no atmosphere. So not only does this mean there's no oxygen, there's also no pressure, right? There's no air pressure, which has its own interesting drawbacks and consequences. There's a lot of high-speed space rock floating around out there and dust. And of course, if it's in orbit, it's moving really, really, really fast. And then there's basically the unusual experience of kind of low gravity situations. So if you were to venture out without protection into kind of one of these environments, first you would lose consciousness, right? Very, very quickly. And that's because there's no oxygen. Okay. Then, because there's no atmosphere, your body fluids would boil and then freeze, and that's because of the high and low temperatures, right? So your body fluids would go through these changes, and this would be terrible. Your tissues would expand and possibly even burst. This is because of the no atmosphere and the low pressure situation out there. Your tissues would be alternately cooked and then frozen as you went from being in the sun's light to not being in the sun's light. High exposure to radiation and bombarded by bullet-like dust particles. So obviously not the best environment for a human being. So what do? Well, we put on some spacesuits, and we've seen them, especially when we've seen people kind of like servicing the International Space Station when they're out on spacewalks. So what do spacesuits provide to us, right? So first of all, oxygen. And one of the things that we get is that there's some O2 in tanks that are attached to the astronaut. But the main supply is through the umbilical. And that, you can almost see it here in the diagram. This right here is kind of a tube that attaches into the astronaut spacesuit and provides oxygen to the atmosphere, to the astronaut. Okay. The spacesuit also provides carbon dioxide removal, and this is also done through the umbilical. Okay. And there would also be a life support backup here. A life support backpack. It would also probably help with that. That's where kind of the oxygen tanks would be stored as well. In kind of the backpack that the astronauts have, there would be a mechanism by which, if they were ever detached from the umbilical, that they would have this life support kind of backpack that would also help with this. Okay. The other interesting thing is that the spacesuit provides a pressurized atmosphere. So what this means is that the spacesuit is inflated similar to a balloon, or similar to how we would inflate a balloon. It's got about 1/3 of Earth's pressure. So not quite the same as what it would be like on Earth, but closer than, of course, a vacuum. So it's got about 1/3 of Earth's pressure, and so it stays all puffy. Okay, and that's important. That's really, really important. Temperature control. This is huge. So we have heavily insulated layers of fabric. So heavily insulated layers of fabric. We have reflective outer layers. Mainly the reason why we have a reflective outer layer is so that the sunlight, much of it will bounce off of us and not be absorbed. And then we also have, in the Apollo missions, we had fluid-cooled garments. Fluid-cooled garments were used in the Apollo missions. Okay. We also get some space dust and tear protection. Obviously, you can't have a tear in your spacesuit. And so these, basically, they act just like bulletproof vests with Kevlar. And that's so that we don't get any rips or tears. And last but not least, we have some radiation protection. It's limited. We've got some reflective coatings. And ultimately, though, spacewalks, anytime when they're going to be out, spacewalks are planned to avoid solar flare activity. Okay, so let's take a look at the modern spacesuit that we use. We have 13 total layers. 2 of them are for the inner cooling garment material. We have 2 layers of pressure maintaining material. We have 8 layers of thermal and micrometeoroid garment materials. So this is like the Kevlar and the heat. And then we have 1 layer of outer covering. The total mass of all of this is 130 kilograms. And if you do a little calculation, 130 times 2.2 is 286 pounds. If you can believe that, that is a massive suit to be wearing. The thickness is only about 0.48 centimeters. The pressure that it's kept at is 0.29 atm, which is almost 1/3 of Earth's atmosphere. And the cost, a whopping $12 million. So this is what it costs to keep us basically safe from the dangers of space. Of course, one of the reasons that these can be so heavy is because we are out in space, so we don't have the same force of gravity pulling us down. It would be really hard to walk around with something that's almost 300 pounds covering our bodies. But here it is. These are kind of some of the dangers of space and how spacesuits help protect us.